white hacker do? So a pen tester will impersonate a black hat, a bad guy who is trying to break things, and try to find any vulnerabilities, any security issues before bad guys will find it. So simulating the hacker attack, right, is the essential way, an essential goal of the pen tester. So what will be our task, assignment? This will be our assignment for today. So what we will try to do is we'll try to take a MySQL server or PostgreSQL server and then hack it, own it. So the first step will be to try to establish any database connection to the database. The second step will be to escalate the privilege. And we escalate the privilege to the root user or something else user to be able to read a private database or get the password of the admin user. While we have that root user, we'll try to do a database escape. Escape means that we only have, at this point, at step one, we only have a root connection to the database. But what we will try to do is we will try to get a shell to the server where MySQL is running. And finally, we will try to attack this poor guy, DBA, MySQL DBA. We'll try to attack the DBA's workstation. So this is our plan. The ultimate goal is to own not only MySQL, but also the workstation of the database administrator that connects to the MySQL. So how do we do that? So step 0 is to establish a database connection. Again, let's imagine that we have a MySQL server or PostgreSQL server. How do we actually establish the connection to it? Usually we have an application server and we have a firewall. And the firewall protects the direct connection to the relational database. So we have two options here. The first option is if the database is exposed to the internet. If it's database exposed, we can try to do a brute force attack, or we can find a CVE that will allow the unprivileged connection to the database. Actually, that happened before. If it's not exposed, then we can go through the SQL injection. So for the purposes of this exercise, for this assignment, we will be trying to connect to the database through the application server, through the SQL injection. This is just an example of what injection is. Right? So we have an application server that takes the parameter, this case published parameter, and it concatenates the string. And the string will go directly to the MySQL in this case. So we can change this published and get an access to the MySQL. So we can do very easy stuff. We can create a union and try to retrieve the MySQL password from it, right? But that would be too easy. Usually the configuration is correct. An application user should never have even a select to the MySQL system database. So what if we don't have MySQL user access? So now the things are getting more interesting. And what I will do is I will go through the fictional example of this fictional database architecture. So let's imagine that we have found, as a pen testers, we have found a WordPress website. And we were able to execute the SQL injection using some vulnerability in the WordPress. And then we get an access to the WordPress database. But there is nothing interesting here. What we are really looking for is to access to another database which holds the health records database. So imagine I don't know, a health care company holds the website. And this is just about us website, WordPress based, nothing there. But on the same database server, they have the customer data. It's protected by the different users in MySQL. So can we get here? If we get the user that only be able to read the WordPress database, can we get here? Also, MySQL database is protected. So if we try to do select from the MySQL.user, we'll not be able to do that. So let's examine the users that we have on the system. We're not at we haven't hacked the system yet. We are trying to examine it from the architectural perspective, right? So this is how it's configured. We have an admin user, a root user. We have a corp WordPress user that can only access one database. And then we have a health data service user that have the access to the database that we are looking for. We also have this weird monitor user. So what is this? So let's examine again the grants that we have. We have a WordPress user that has an access to the WordPress database. We have a health data service user that has an access only to the health data service database, which contains the customer data. And then we have this monitor user, which have select, have execute. And this is global. So this monitor user has a select on everything. So the question is that what is this user, why it's there, and how we can potentially exploit it. By the name of this monitor user, I can imagine what it is. But let's first see if we have, what kind of grants we have. So we have this unprivileged user, and if we try to select from the MySQL.user, we get a command denied. And the same will happen if we'll try to access the healthcare database. But the monitor user at the same time have ability to select and have the ability to retrieve the passwords. Why is that? Because this monitoring user have a global select. So let's guess what it is, what this monitor user is. It may be that this is used by Percona Monitoring and Management Platform, PMM. It may be used by MySQL Enterprise Monitor. It may be a custom dashboard that's using this user. Or it may be that a MySQL DBA will use that account. So the question is, will this monitor user connect to our database and will it run the explain plan? So imagine that this PMM system or Enterprise Monitor or MySQL DBA will constantly run the explain plans to understand which queries are slow or not slow. So the explain will execute the select. If you run the explain plan, you put the select statement, will it execute it? Should not, right? But in some cases, actually, it can execute. So what will happen is that explain usually just need to provide the statistics, the information about the plan. But then, this has been published at Percona blog post a while ago. Actually, if you provide a function inside of your select, and you run the select, then what will happen that explain will need to materialize the subquery with a function to be able to provide the accurate information. So what will happen is that you run the explain, it will run the select, and it should not. So the question is, can we exploit it? Can we actually get a privilege escalation using a different user? So this is actually called confused deputy problem. The confused deputy problem is a program that has a different set of privileges. And it doesn't know that you are abusing that. You're asking the monitoring user to run the explain plan. And then inside of the explain plan, you put your poison, a payload. So let's see how it works. Right, so what we will be doing, how we will escalate the privileges. We will craft a specifically slow query, which will then be explained by our monitoring system or DBA. And then this query will be executed as a monitoring user. So also an attacker, we in this case, can create any tables, functions, stored procedures in the WordPress database. Again, remember, the user that we get an access to have all privileges to the WordPress database, including the create table and insert and update. This is actually a very common configuration. You provide, you find the open source solution and you provide the user to that open source solution. So this user can do everything for that WordPress database. So let's create what is called a security proof of concept. First of all, we'll create a function, an exploit function. And what we will be putting inside of this function is we are trying to retrieve the password for the monitoring user. So we create this function, exploit, and then we make this query slow by calling select sleep. And then, again, the monitoring user has a global select. But the question is, how do we get this password back? We can select, but how do we get the password back? So what we can do is we can use another function. We call it save function. So we have this definer thing, right? And definer, if you know Linux, it works as suid, right? This function will run in the context of the definer. So we create a function with our definer. If we create this function with our definer, we'll be able to write to our database. So we create a function save, pass the password as an argument to that function, and put that function inside of our exploit. So this is our function, exploit function. It will be slow. We made it slow. We run it with a SQL security invoker. So whoever runs this function, the privileges of that user will apply here. So we retrieve the password and we save it. Again, when we save it, there will be a switch, a change of context, a security context that will be executed as our user. So the monitoring user will run it. Monitoring user only has select privilege, but because we are saving with the definer, we'll be able to write. So this is how it will work. I have recorded this demo. Now let's see. Let's start. So we have a car on the MySQL DBA is here, and our bad actor is here. So I need to switch here so I can see. So we have our current user. We don't have anything in the P. So we'll create this. We have a save function. We'll create. We have created the table to save it. And then we will run our poison query. So this is subselect. Inside of the subselect, we have an exploit. This query is slow. Now imagine MySQL DBA will try to understand why this query is slow. And we'll take this query and run it from its own user, from the monitor user, and we'll run the explain. So what will happen then? Well, it's not helpful, and it's even Strange that this query is not slow from the MySQL DBA perspective. But now we have a password. So the password has been saved because the monitoring user has an access to the MySQL user table. All right. So now what we will do, we retrieved the monitoring user password. What would we do with that? So the next thing will be to try to crack the password. Right, and here I started my hashcat, a program to crack the passwords. I specify the specific, I configure the hashcat. I put in options to the hashcat to be able to crack the MySQL password. And let's see. Any guesses how long will it take to crack it? And I'm using this rocku TXT file. That's the common passwords. So let's see, this is my string. I remove the star from it, run the hashcat, and let's see, starting. That's it. Less than a second. And why is that? Because the password is pass. So why the password is pass? Because it's unprivileged monitoring user. So whoever created that monitoring user was thinking, well, it doesn't matter. This user doesn't have much. It doesn't have the whatever information that we will care about. So whoever created this user created this super simple user. So at this point, we escalated our privilege. We confused our monitoring system or database administrator into running explain of our statement that we control. And actually, MySQL in this case, MySQL explain can actually execute the statement. It should not. And monitoring user, also the essential part of that is that the monitoring user not only have this bad password, but has execute privileges. It has a global select and an execute privilege. Because of that, we were able to trick it, run our statement, and retrieve the password. So at this point, we got a monitoring user password hash. It was simple password, easy to crack. And the result is that the attacker can now connect as monitoring user and download the whole healthcare database because it has a global select. All right. So far, we achieved our goal. Yes, go ahead.
Just a question. Were you able to crack as quickly the new authentication password?
I haven't tried. It will be definitely much more complicated, much more time consuming. But if the password is pass, it will probably be much easier to do. So I haven't tried that. Of course, the SHA 256 or caching SHA 256 plugin is much harder to break. All right, so we get to health records database. So what's next? Well, before we'll go next, what about Postgres? I don't have a proof of concept for Postgres, but I believe that that's more complicated, but still possible. Postgres have, and MySQL also now have explain analyze, right, which actually execute the query. But the challenge here for Postgres is how to create a statement which will be executed when you run explain. All right, so what is next? We have a full access to our relational database in MySQL or Postgres. And now what we want to do is we want to escape from the database protocol and get a shell on the actual operating system. So this is what we will be doing next. We'll be escaping from database to OS, and we will be getting reverse shell. So let's imagine that we have admin database connection, root database connection, and we need a privileged operating system command execution. What will it give us? Why do we want that? This will give us the full control over OS, and also will give us an ability to replace the whole MySQL server with something else. Before we'll go further, we have different options here. With MySQL, the architecture is that if you get a shell, if you get a super user, a root user, does not necessarily mean that you have a shell. You need to find some of the way to do that. At the same time, if we're talking about PostgreSQL, then you get super user, you get shell. I will provide a very small demos, recorded demos of how that works for Postgres and how does it work for MySQL. So for PostgreSQL, we have this copy from program or changing archive command, which make it very easy and trivial to get shell. So here's the demo of the reverse shell. And I will explain along the way. See if it will work. Can you guys see it? Hope so. I cannot see it from here. All right, so what we're doing is we will create a table. And this is Postgres. On top, there is a Postgres. On bottom, there is a OS that bad actor controls. We run a listener, we run the copy from command, and we get a shell access here. So that is that easy. On the bottom, we have the ability to execute any OS level commands from the context of the user that runs the database, PostgreSQL in this particular case. Right, so this is Postgres, MySQL. MySQL is actually much more complicated. You need to, the common way of getting shell escape is through the UDF. But the problem is that with the UDF, you will need to create a user-defined function. You will need to upload it to the plugin tier and stuff like that. I will not be doing demo. I simply don't have time for demo for MySQL. But if you Google sys UDF, then you will get the idea. And now, much more interesting. So we get here. We now fully control the database. We have OS user. And now our task is that we want to control the database administrative workstation. So MySQL have a history of things like if you get an access to the server, you can read the file. This is very old vulnerability, and I will not be talking about that much. But this is very old known vulnerability where you can replace the MySQL with a rogue server. And whenever MySQL client will connect to it, you, meaning the rogue server, can read an arbitrary file from the MySQL client side. So this is actually DBA, right? Or whoever connects to the MySQL. And if a bad actor controls the server, get a shell access, even an unprivileged shell, can replace it with a rogue server and trick the client to give arbitrary file. Right? So this is what we can do, replace MySQL with a rogue server, and then change the query with a load data local in file. So load data local in file, it's pretty dangerous, and it's, I would say it's very bad implementation. So it will, the server will allow to give commands actually to the client, and the client will reply with with the actual file. So now this has been fixed, 2018. Now, as a pen tester, reading a file is okay, but my ultimate goal is to execute the code. That's what I want to do. So this is a scenario that I will be talking about and demoing today. Your MySQL DBA connects to the server. Server is owned by our bad actor. And the bad actor will start controlling database administrator workstation. I mean, it can be any client, actually. It can be a web server. It can be a MySQL DBA. It can be another system that connects to the MySQL, like monitoring system. So how this is even possible? To understand how this is even possible, we'll need to look at the auth phase. How does MySQL client perform authentication against the server? So I have created this oversimplified presentation of how this connect phase and auth phase works. So MySQL client connects to the server and say, hello, MySQL server, I want to auth. And I have a username password. But in addition to the username password, MySQL client will specify what is the plugin it will use. And usually it is something like MySQL native plugin or caching SHA-256. So in this case, a MySQL client uses MySQL native password plugin, and it will tell the server that this username and password and the plugin this will be used. So the server will say, very good. I loaded MySQL native password plugin, and I checked your username and password, access granted. Now, MySQL supports this pluggable authentication. So instead, our client may say, hello, MySQL server. I have username and password, and by the way, I will use whatever plugin. So the server will check and say, I have no idea what this whatever plugin is. Let's try another plugin. So what will happen there, MySQL client will comply and say, okay, I'll try this another plugin, if I have it. So what does that really mean? This is protocol level. MySQL server can actually tell MySQL client what to do. It can tell, load this plugin from disk. And what does load actually means? The plugin is a shared library. MySQL client will be able to perform the loading of the shared library. On Linux, it's called DLOpen. On Windows, it's called load library. So it can do a call. And this is this, right? So that means that we can potentially execute the code on the client by simply telling that from the server side, initiating that from the server side. So let's examine the code. This is the code. This is client library. That's not a server. It's a client, but it's a part of the server. Because MySQL command line client, for example, or libmysql is a part of the server. It compiles with the same thing with the server. So this is in SQL common, right? It's called client plugin. And then what it will do is it will take the plugin name that comes from the server. It will take it from the plugin dir, and it will DLOpen. So what kind of protections do we have? We have a plugin dir. And plugin dir you cannot change. You cannot change from the server side. You cannot change it from the client side unless you have a full control of that, right? So plugin dir is a configuration option, and on the client you need to be able to write to a config file, which we cannot. But we can try to use a directory traversal. So what if we supply the plugin name, which is .. Then what will happen is that this code, at least, it will just do a del open. It will also append the SO, right? Where am I? Okay, it will append the SO, and then it will do del open it. So that means an arbitrary code execution via directory traversal. Does it really work? Let's see. So this has been actually found and fixed in 2019 for both MySQL and MariaDB. I was trying to find out how this was fixed and what was the source of that. And eventually, it was a HackerOne report against MariaDB. And this guy has found the whole thing, reported it, and it even have the exploit code there. So what happens is in 2019, in June, it was reported via HackerOne and accepted by MariaDB team. And in August, it was fixed and released in MariaDB. So what they did is they start sanitizing the input, right? This is good. So the plugin name actually should never contain all these characters, right? It's just a name. So they remove this, they're starting removing these characters from the plugin name. And then November 21st, the fix was pushed to MySQL community. I don't know what actually, it was some release out of that. I can only see the commit, right? This has been assigned the CVE. I don't know the actual CVE. Oracle doesn't provide this information. It has a private bug number, and this commit have this explanation, what can happen, right? A directory traversal. So let's try to use this exploit, assuming that we have an old 2019 server, and try to see if it will work. So the fix is actually there, and it's sanitizing the input. It's actually in MySQL Server, Oracle MySQL Server, well, MySQL Community Server. It's a different implementation from MariaDB. So let's first get the summary of the directory traversal. So all the MySQL and MariaDB versions are vulnerable. What does that mean? Server can push the full path of the shared library to the client, and the client can load it. Assuming that this code is there on the client side, it can load it. So a malicious server, a rogue server, can push that. Fixing-wise, it's fixed in MariaDB versions here. MySQL fixed in 5.6, 5.7, 8. So what we will be doing for the purpose of this presentation is we will be using MySQL 18 version, and we'll see if we'll be able to create a proof of concept to be able to execute the code. So again, we're here. This is our goal. So how does it work? We assume, for the purposes of this proof of concept, we assume that we have a MySQL MariaDB server, any version, server doesn't matter. We have a vulnerable old version of client library. And our DBA is using MySQL command line tool or MySQL GUI tool, for example, MySQL Workbench. So we control this MySQL server. We need to have the vulnerable version. We need to also ability to push exploit code here, right? Because we don't control, obviously, we don't control the workstation of our MySQL DBA. That sounds complicated, right? So let's see if we can do that. So the first thing that we will need to do is we'll need to write a rogue server with the ability to push the plugin. There are two ways of doing that. We can create a auth plugin and load it to the existing server, or we can create a fake MySQL server in Python. I decided to create a rogue server with a MySQL Python. So this is our plan. We need to write a rogue server. We will need to have a loading of arbitrary file as shared library, and we will need to somehow push this exploit code to the database administrator machine. Let's start with number one. So I have been using this MySQL mimic Python module. And I was able to create a fake real MySQL server, fake real server. So that supports, actually this MySQL mimic is pretty good. It supports SSL, it supports all the features, it's very flexible. So I was able to write a rogue server which will push the plugin name that I supply from the command line. Right, so I created this, overloaded this class, custom identity provider, and pushed the plugin name. And here's how it works from the main function perspective. Right, it takes the arguments. It takes the argument, the plugin name. We need the directory traversal. Port, and that's it. So this is our exploit proof of concept. And for the purposes of this, I took the ODBC driver on my Mac system. And I configured this ODBC driver to connect to my rogue server. And then I just click test connection or something like that. And this is the result. So we have our old MySQL client here, 8018, before the fix. And now we use that, and we see that it says cannot be loaded. No such file. That actually means that our exploit succeeded because it tried to load the library. So our injection worked. So step one is done. We wrote a rogue server with the ability to push plugin names. Now we need to load an arbitrary name as a shared library. So we need a shared library. We need a code. Right? So the problem is, how do we actually load the exploit code? This exploit code should technically be a plugin. We need to, so server or client expect this shared library to be a valid auth plugin. But the good news for hacker is that it will use the DLOpen mechanism, and DLOpen will find the init part of that shared library and load it. So we don't even need to write a valid plugin. We can write this. This is on Linux. We can create an init part of the shared library and put whatever. So what I'm doing here is I put the calculator app, and I open the calculator app, and I compile the shared library, create an SO file, and then I will be able to execute my code. So it will also be nice to be able to use an arbitrary file name. Remember, this function actually appends .so. But the interesting thing is that this function is from 1984. And that has been written by Richard O'Keefe, who is a very famous computer scientist at that time. That may be one of the oldest part of the MySQL code still in production. So we can see here that it is using this fnreflen, which is the define. And basically that means that if we will overload and create a long name for the plugin, we will be able to do a length overflow. So that means that if we create a long name, it will not append the .so. So how will it work? We use this unfixed 8018 old client. We use the rogue server in Python. And we generate an overflow string. On Linux, it doesn't matter how many slashes we have in the path. We can also have multiple ... /.. So I'm generating this traverse, and I specifically generating a very long traverse string to be able to pretty much overload, or like create a length overflow. So with this, I have the ability to load arbitrary file. It does not necessarily need to have SO. This is the function, generate, and then the updated start rogue server code, which will use that function. Right? So now I can try with something like this, PNG. So I create the TMP PNG file, like a image file, right? But in reality, it is actually the shared library. And I can pass that, file path and then get code execution. All right? So I use this MySQL, I connect to localhost, I connect to the port. This is the server that I control for the test. And then I get whatever it is, authentication plugin. It cut off the error message so I don't see it. But if I run strace, I can see that it's actually tried to load it. So now the most tricky part, how to push the exploit code to the database administrator machine. Any guesses? How would you do that? Well, we have the ability, potentially, right, to use a classic method of finding a target, a DBA, and use some sort of social engineering. So I can find, let's say, Fred on the LinkedIn and send him my resume. And this is PDF file, so the Fred will take this resume and save it on disk. That's the only thing I need. No need to trigger the execution at this point. I only need the file, arbitrary file name, to be on the database administrator machine. All right, so we're running a little bit out of time, so I will skip the demo. I have the actual demo there. I will do that afterwards. I have the live demo. I have a recorded demo as well. But let's let me go through the last part of this presentation, and this is what we have found recently. And then after that, I will do the live demo. All right, so let's skip that. And have a Windows demo. Let's skip that for a second. So the new discovery. In February, February, right? In 2023, we discovered a new security issue. So let's take a look. Let me first go through the timeline. We discovered a new security issue to bypass the fix. So we discovered a bypass to 2019 fix. remember the 2019 fix actually checks the plugin name, try to find the // right? So in April 18, 2023, the issue that we have discovered, the bypass, was fixed. So now we're all good. We need to be running MySQL 8033 or MySQL 5742. The bypass only affects the community MySQL. It doesn't affect MariaDB. All right. And here's the description of that. So what we have found is that if we use the UTF-16 characters, then this UTF-16 characters will not be checked. So let me go through the code. So what does this actually means, right? So this is the fix of 2019 issue. It will use this myString CPN function. But what is interesting is that it checks the character set first. And it has a different code for UTF-8 MB4 and non-UTF-8 MB4. But you can also see that it skips through the code. I think I haven't included that. But the question is, what if our client char set is UTF-16? What will happen is that it will skip over the 4 bytes. So if the char set is UTF-16, this protection doesn't work. Well, the UTF-16 is actually not supported in MySQL client, but still, this will work. So let's say that we take the newer version of MySQL Workbench, and this is the version before the fix, 8030. And we supply the Workbench with the opt char set name UTF-16. Right? Then what will happen is that it will skip over this. So let's take a look. I have recorded this demo. And then I have my calculator, right? Because I have my plugin there, which I have created, and will execute the calculator. So if you provide the character set, if you will be able to actually use, or if the DBA is using UTF-16 character set, then this. So let's take a look at the command line. And let's see. Right? So this is Windows. And we have this DLL. And we created this DLL with the actual exploit. So now we have the version. This is version 8032, before the fix. And then what will happen is that we will provide this additional option. So let's say that we just do it like this. The fix will work. No paths allowed. But if we will add default character set equals UTF-16, it's actually executing the code. So this is the vulnerability that we found, and this what has been fixed in the latest version of MySQL. If you use the latest version of MySQL, 0.33, and you attempt to do the same thing, connect to the rogue server. It says no parts allowed. That's the 2019 fix. Now we try to do the default check to set equals UTF-16. And you can see that it will disallow the UTF-16 as a check to set for the MySQL command line. So this has been fixed. All right, so our plan of attack is done. We have successfully wrote a rogue server with the ability to push the plugin name. We have the ability to load arbitrary file name as a shared library, not necessarily it needs to end with a SO. That helps a lot. And then we push the exploit code to the database administrator machine, and we're able to execute the code. The demo shows the calculator or just a pop-up window. So let's recap of the vulnerability. 2019 issue, original old versions of MySQL MariaDB Percona server earlier than October, November 19, 2019 are affected. Again, this is client, right? This is not a server, this is client that is being affected. 2023 issue, the UTF-16 check to set bypass. The fix is released in April 2023. And you will need to upgrade. If you're using MySQL community version, you will need to upgrade. What else is affected? MySQL command line client tool, MySQL, GUI tools based on libmysql, connect to C++, ODBC driver, and actually any driver based on libmysql, like ODBC driver, for example. For the GUI tools, all the versions before 2023 version, MySQL Workbench, Navicat, SQL Pro, whatever you're using is potentially affected. So make sure that you upgrade to the latest GUI tool if you're using it. GDBC on native implementations like Go, Python native implementation is not affected. All right. So summary, rogue MySQL server can attack the client, and everyone who connects to the untrusted MySQL server is at risk. Original issue was fixed in 2019. The new issue was fixed just in April. So using multi-byte unsafe string comparison is pretty dangerous. That's a lesson learned from this research. And then MySQL code has functions. If you didn't know that, it has functions from 1982, 1984. So those functions may not work properly with the multi-byte check sets that never existed, that didn't exist at that time. All right. So conclusions. You need to protect your application from SQL injections. That's the first thing. You need to use prepared statements, sanitize input. You need to grant only what is needed. If you create a user, a monitoring user, don't grant that user execute, right? Be very careful with what grants, what privileges you provide to that user. And always use the latest versions of MySQL and PostgreSQL, including the clients. So now, I would encourage all of you to check your MySQL command line tools and GUI versions and make sure that they are the latest versions, including the whatever command line client or workbench or whatever. All right. So before we'll finish, I know that we're running over time. I really wanted to show you the live presentation, the live demo of the stuff, if this will work. So let me see.
missed one line in the conclusion. Never open the CV or the resume.
This is very interesting. You don't need to open it. Never save it. Never even accept the resume from untrusted source, especially from me. All right. So let me see if I can do the demo. So this is my workbench. And I connect to this MyHack database. This is a virtual machine that I have. So let's see about workbench. Does it even work? If it will not work, I will do the recorded demo. No, I don't want. Well, yeah, I can close. All right, this is my workbench. This is version 8013, pretty old. Do you have anyone using workbench 8013? Just delete it. Don't use it. Too old. All right, so now I have my hack database here, right? And I connect to this. So now I have my virtual box running, and I have my terminal running, and I have my shared library, right? So then I will be using Martin's resume for the demo, right? So this is from the previous run, right? So this is my script, rogue.py. I started it. I specify the path here to the, well, PDF file, as I thought. And this file doesn't exist on the server. It exists on the client, on my workstation. I specify the port that I will be running my server. And I also need to know the plugin dir, because I will be calculating the injection path from the plugin dir. So now from here, I have configured this workbench using the plugin dir. Now let's see, that's a moment of truth. We will use test connection. Here we go. Calculator runs. So my shared library, the resumes are actually shared library. It exists on my workstation. And this shared library actually opens the calculator. That's a demonstration that this exploit works. Instead of calculator, we could have created a reverse shell or something that will allow us to access the DBA machine. So that's basically that's the demo. There is another demo for Windows, but we can skip that. All right. I think that's it. Any questions?